Hello friends, this is Naina Jangle from Department of Electrical Engineering, Kekewag Institute of Engineering, Education and Research, Nasik. Today we will discuss a numerical on first order curve fitting, that is fitting a straight line using least square approximation. The least square method is a form of mathematical regression analysis used to determine a line of best fit for a set of data, providing a visual demonstration of the relationship between the data points. Each point of data represents the relationship between a known independent variable and an unknown dependent variable. Objective of today's session is, at the end of this session, student will be able to apply formulas of normal equations of least square approximation to fit a first order curve or a straight line for given number of data points. The least square method is a statistical procedure to find the best fit for a set of data points by minimizing the sum of offsets or residuals of points from the plotted curve. Least square regression is used to predict the behavior of dependent variable. Okay, so these are the key features of least square approximation. That means this is a statistical method to find the relationship between two data points, one dependent variable and independent variable. So we can predict the dependent variable value from the independent variable by using least square approximation. Now the question is to find the equation of a straight line to be fitted into following data points using least square approximation. This question may be asked for 7 marks in the examination. Now here in this equation, in this problem, here x is a independent variable and y is a dependent variable. So y is a function of x. Now we have to find the relationship between these two variables x and y. Now we can fit a straight line equation y is equal to ax plus b for the given data points. Actually, we can fit nth order equation for the given data points also, but as per the given data points, it is observed that the equation may be a straight line. So we can, as per the requirement, we will fit a straight line for the given data points. So according to the least square approximation, normal equations for the for fitting a straight line curve for a given data points is given by a sum of xi square plus b sum of xi equal to sum of xi into yi. This is equation 1. A sum of xi plus b into n equal to sum of yi is equation number 2. Here n is the total number of data points given in the problem and I starts from 0 to n minus 1. The two equations, equation 1 and 2, can be written in the matrix form as follows. Okay, so these two equations can be written here as in the form of matrix. So multiplier of A is sum of xi square and sum of xi, whereas multiplier of B is sum of xi and n and equal to constant sum of xi and yi. So these two equations are called as the normal equations of a least square method to fit a straight line. So for solving the normal equations to fit a straight line, it is necessary to calculate the sum of xi values, sum of yi values, sum of xi square values, and sum of xi and yi. So as per requirement from the given data point table, we will calculate here sum of x, sum of y, sum of xi square and sum of xi into yi. So for the 7 number of data points, sum of xi is 52, sum of yi is 142, sum of xi square is 664, and sum of xi yi is 1340. So here we get sum of all these values. Now putting all these sum values in the given equation, equation 1 and 2 here written in the red letters. So a sum of xi square plus b sum of xi equal to sum of xi yi, where a sum of xi square is 664, b sum of xi that is 52, and sum of xi yi is 1348. Similarly, for second equation, a sum of xi plus b into n equal to sum of yi. So a sum of xi is 52, 7 the number of data points into b equal to sum of yi is 142. So after getting these two equations, equation 3 and 4 from the normal equation, we will get the values of a and b by solving or by eliminating one by one values of a and b. So after solving these two equations, we get a equal to 1.05556 and b equal to 12.4444. So for the given number of data points, the straight line equation y is equal to ax plus b, where a is 1.05556 and b is 12.4444. This a and b must satisfy this equation y is equal to ax plus b at any point given in the problem. So then only this curve is said to be a best fitted curve for the given data points. So what is required to fitting a straight line for the given data points? It is necessary first to calculate sum of xi, sum of yi, sum of xi square, and sum of xi into yi. And our aim is to find these a and b values so that the straight line equation y is equal to ax plus b must satisfied at any values of x and y. Then only we will fit a best curve. Now one exercise for you. The exercise is fit a first order curve for the following data. Here x is given in degrees 0, 10 degree, 20, 30, 40, and the cos x is given. Here cos x is nothing but y. So y is a function of x. So we have to fit a straight line curve or a linear equation between cos x and x. So as per the requirement of as per the requirement of least square approximation, it is necessary to calculate sum of x, sum of y, sum of xi square, and sum of xi yi. So you solve this problem, you calculate the values of sum of x, sum of y, sum of xi yi, and sum of xi square, and you will get these two equations: 3000a plus 100b equal to 85.26 and 100a plus 5b equal to 4.5565. So after solving these two equations, you will get a value as minus 0.0058 and b equal to 1.0287. So if these two values a and b are such that these are satisfying these all data points x and y, then only we can say that y equal to ax plus b is the best fitted straight line for the given data points. So at the end of this session, we can apply the normal equations of a least square approximation to fit a straight line for the given number of data points. The data points may be 10, 20, or n number of data points. Then you will get the relationship between x and y, that is independent variable and the dependent variable. Okay. So hope you understand fitting a straight line curve for the given number of data points. Thank you.